Well, thank you for getting up early and coming to the session. We have I think, a fantastic session on the perfluorinated chemicals. And Minnesota has been dealing with these for, I'd say, at least 15 years. So they're not chemicals of aging concern yet here in Minnesota, but they're probably not as emerging as in some areas of the country. They also continue to be very challenging chemicals to deal with. So the first speaker, who will sort of set the stage for us in terms of the the situation here in Minnesota, will be Ginny Yingling, and so I'll have her come on up because we band schedule.
All right. Well, good morning, everyone. As Helen said, I'm going to be lead-off batter for the team and try to set the stage for the work that's been ongoing in Minnesota. And I just wanted to recognize my two co-authors on this talk. That's Jamie Wallerstedt over at the Pollution Control Agency and Shalene Thomas, who's actually here this morning from Amick Foster Wheeler. The end of my talk, I'm going to be focusing on some work that they've been doing in the part of the talk, hunting for other sources in Minnesota. Probably don't even need this slide anymore for most folks, but poly and perfluoroalkyl substances, PFAS, the new annoying term that we have to use instead of saying PFCs, are a large class of surfactants with unique chemical properties because of their fluorinated carbon chain. And they've got, as you can see here, a wide range of uses. Minnesota came early to the party because of production of some of the chemicals used in making a number of stain-resistant and non-stick coatings. But we also have a number of sites associated with chrome plating. PFOS-based compounds are used as a film on top of the tanks or the vats to prevent chrome fumes from going up into the breathing space of the workers. And like everybody else in the country, we also have a number of AFFF sites associated with firefighting activities. The chemicals we've worked primarily with are the perfluorinated alkyl acids, and the part of my talk where I'll be focusing on the large plume in the East Metro area will help to highlight some of these unique behaviors, the fact that these things are so incredibly environmentally persistent, and yet, unlike a lot of persistent organic pollutants, they are poorly absorbed to aquifer materials, which means they infiltrate rapidly to groundwater. They have little or no retardation, especially of the short-chain PFASs. Their mobility and solubility is largely controlled by the chain length and the functional group, but also the geochemistry of the setting. And the reason the health department cares about this and why we've been working on them since about 2002 is there's chemical structure similarities to fatty acids appears to be why we so readily absorb them into blood serum, where they bioaccumulate, but in a weird way, not the sort of classic way of bioaccumulation. And so we have health concerns even at very low concentrations. As most of you know, last year the EPA issued lifetime health advisories for both PFOS and PFOA of 90 or 70 nanograms per liter, either individually or combined, based largely on animal studies and human correlation studies. I'm not going to get into any details here. That's Helen's job, and she's going to be following on hot on my tail to talk about the health department's new values and how they were derived, because earlier this year we set even lower values for PFOS and PFOA, primarily based on exposures for developing fetuses, infants, and children. My work has focused primarily on an investigation of PFAS in Washington County, which is, as you can see, located just to the east of the Minneapolis-St. Paul metro area. And the reason that we were working on this site is that 3M Corporation has been manufacturing PFASs at that site since the mid 1940s, and waste was disposed of both at the site and at three major disposal facilities that are identified here, up in Oakdale, Lake Elmo, and on the border of Woodbury and Cottage Grove. A consent agreement related to all of these investigations led to funding for statewide PFAS assessments, which I'll also talk about briefly. Early in the process, some extensive sampling in those disposal areas identified the primary PFAS of concern out in that area, and we see these out into the groundwater. So we've focused a lot of our attention on PFOS and PFOA because of their bioaccumulative behavior, PFBA because it's the most widespread of the PFASs that we see in the groundwater, and then PFHXS because some biomonitoring that Jessica Nelson will be talking about revealed that 100% of the people who participated in our study have PFHXS in their blood. But we almost always find these, as most people do, as mixtures, so it's a somewhat complicated picture. What we've got is a combination of some, what in the Midwest passes for complex geology, meaning we've got a few faults in our layer cake bedrock. We also have some deeply incised bedrock valleys that have been buried, so you don't really see them expressed at the surface, but they still act as tributaries to the Mississippi River and the St. Croix River, which bound the southern and eastern part of Washington County. And because of those rivers posing as major discharge points, there's a groundwater divide, which is shown by the dashed yellow line that essentially bisects the county from north to south. So groundwater on the east side of the divide should be discharging to the St. Croix River off to the east, and the groundwater on the west side of the divide should be flowing south-southwest to the Mississippi River. We had hoped that that was going to be the one thing that was going to give us some comfort in the fact that, thank you, all of our disposal sites are located on the west side of that groundwater divide. And so we had hoped that that was going to constrain the area of contamination. And in fact, early modeling of where we were to expect groundwater contamination is shown by these black hash-marked plumes migrating south-southwest from the two major disposal sites in the north. And you can see they're pretty limited in size. But instead, what we have, because of the PFAS persistence, the geology, and then also surface water, groundwater interaction, is a plume that's shown in blue. This is the extent of PFBA contamination. And in fact, this is a somewhat dated map, and the area is actually a bit larger. But we have over 130 square miles of contaminated groundwater. Some estimates say it may be as much as 160 square miles. It's impacted 4 major aquifers, 8 municipal water supply systems, over 1,800 private wells. We've sampled probably over half the 4,000 wells that we estimate to be present in this area. We've had to issue over 600 drinking water advisories for private wells. And as I mentioned, it's an area much larger than models predicted. And the reason that it got to be so much larger is the story I want to tell here, because I think it's a cautionary tale for everybody doing these investigations about the extreme mobility and dastardly behavior of these chemicals. So the distribution, as I mentioned, has been controlled by a number of features, bedrock features such as the buried valleys, also these fault systems that have associated fractures and joint sets, which have been solution enlarged to form karst. And so in some of our aquifers out there, we have groundwater flow rates on the order of thousands, if not tens of thousands of feet per day. So the stuff, once it gets into those karst systems, can really travel far and fast. But the thing I really want to focus on is the groundwater surface water interactions and also some human interventions that have helped to move the contaminants much further than we anticipated. And to do that, I'm going to focus in on a small area up in the Oakdale Lake Elmo portion of the plume. This map shows you the distribution of PFOS in groundwater and surface water in that area. And when we started our investigations, of course, you start in the source area, you work your way out, and we saw what we expected, some small plumes emerging from the disposal areas, migrating with the regional groundwater flow. The chemistry that 3M was working on over the years changed, and so at the time they were disposing of wastes in Oakdale, there were a lot more PFOS and other sulfonates involved, and so we have a much larger plume of PFOS associated with that site. By the time waste was disposed of in the Washington County landfill, the chemistry had shifted primarily over to carboxylic acids, and so we find a lot of PFOA and PFBA, but very little PFOS. And so in the source areas, the groundwater is shown in kind of this weird pinkish purple color. We have over 6,000 nanograms per liter, and actually in older samples even higher than that of PFOS in the groundwater at the Oakdale site. But we had one well that even came close to 1 part per billion, 876 nanograms per liter at the Washington County landfill. And as you can see, very quickly the concentration drops off to non-detect to the south of that landfill. And yet, as we expanded our analyte list due to the great work of our chemistry lab, who's well represented here this morning, we started analyzing for more than PFOS and PFOA in 2006 and started finding PFBA everywhere. We extended our investigation area, and as we started chasing that that low concentration PFBA plume, we started finding hotspots of PFOS that seemed to be detached from the source areas. And the only thing that we could really suss out about that was that everything seemed to be down gradient of this surface water, Raleigh Creek, which once we walked the dry creek bed went all the way back to the Oakdale disposal site. And in fact, sources out of a small lake and some wetlands to the north of the Oakdale disposal site. And as we started sampling both surface water and groundwater along the course of this drainage system, we started seeing very close correlation between the concentrations in the surface water and nearby groundwater wells, some as much as 300 feet deep, and yet the concentrations are nearly identical all along the course of this system. We've only recently been made aware that the system actually extends even further than we thought and ultimately discharges out to the St. Croix River. And so recent sampling along that part of the system has shown us that we've got contamination all the way out in the drainage, including about 220 nanograms per liter discharging directly into the river from the end of the pipe. We've also taken a look at tributaries and surface waters feeding into this because we didn't know, well, are there other sources that are adding to the problem? Are there other areas we ought to be investigating? But in the light gray numbers you can see here, these are the small lake at the headwaters of this system as well as some of the tributaries, and we don't find anything except what you'd expect for either non-detect or atmospheric deposition or surface water runoff concentrations of PFAS. So the pathway that we've sorted out, and that's so surprising for a persistent organic chemical, is that we've got normal groundwater discharge, but then the groundwater is also discharging to that surface water. It flows along Raleigh Creek where it's a gaining stream, but once it gets to the city of Lake Elmo, becomes a losing stream. And so groundwater, it's losing the contaminants into the groundwater and discharging through the entire course. It enters a lake, also discharging to the groundwater, down gradient of that lake. It flows through the groundwater over to Lake Elmo from Eagle Point Lake, across that lake, into the groundwater again, impacting wells. It's also being transported via a pipeline across the bottom of the lake into Horseshoe Lake. From there, it goes into the groundwater. It travels through a series of ditches and ponds, again, infiltrating and impacting the groundwater. And then through the pipeline to a stormwater rest area stormwater pond, where it also infiltrates and impacts the groundwater and down gradient wells. And then finally into the St. Croix River. So we've got a very complex system of transport of these contaminants and all these distinct little plumes that might confound you if you started at the east end of the system rather than the front end. So I want to caution anybody who's working in this area, if you've got any surface water near your site or even a stormwater system that's going, a stormwater sewer that might carry contaminants away from your site, you've got to go look and chase down wherever that surface water is going and then looking at the groundwater along its course. We've had a number of response actions associated with this plume, a large-scale excavation and containment of the contaminated soils and sediments, groundwater extraction and treatment, treatment of drinking water systems. You can see the Oakdale City treatment system, as well as the kinds of carbon filtration systems we're installing in people's houses. And we've done some biomonitoring, which Jessica is going to be talking about shortly, and a home and garden produce study that was conducted by Deanna Shear and others at our office. She'll be talking about that later. Statewide, there have been a whole slew of investigations by both the Health Department and the Pollution Control Agency. We'll be having talks by Pat McCann this afternoon about about our fish consumption advisories on PFAS in fish. And Summer Streets will be presenting on some of the statewide fish sampling and how that led to another PFAS release site being discovered. Finally, the Pollution Control Agency is doing work to try and systematize the effort to hunt down sources of PFAS. The goal is they just completed a pilot study in 4 counties looking at databases, publicly available databases to identify potential PFAS sources. And then evaluated potential receptors near those sources. The next phase of that work will be to prioritize the sources that they've identified. I believe there were about 340 of those. And then refining that system, expand it statewide, and then use measurement and validation measurement of PFAS at those sites to determine if they're present or absent, and then use that to validate this process. So I can see my time is up and past, and so I'm going to wrap it up there. And I don't know if we've got time for questions maybe during the transition. We'll have a couple minutes.
I mean, obviously, if you want to get to another session, you'll have to leave. But we have, certain people, if they're staying, we can ask questions. But I will start my talk at 8:20. Thank you. So if there are any questions? Sorry. That's okay. Jaylene has a question.
Yeah.
PFOA, at that facility, did they actually manufacture PFAS, PFOA, the PFBS, all of the ones that you've identified, or are they byproducts?
Yeah, and that's a really good question, Shalene. We know that they were manufacturing PFOA because they were apparently selling it to DuPont and then they were using it in the process of producing Teflon. And that's where some of this all started off, was 3M then alerted both the Pollution Control Agency and EPA that they were going to stop production, hand over that to DuPont themselves, and they were getting out of the PFOA business. Whether I don't know if it was direct production of PFOS or it was, the manufacture of things like Scotchgard, and PFOS was a byproduct of that also for firefighting foams. Our understanding is the PFBA is a byproduct of some of the processes that they were doing, and also some research that was going on at the site. The other thing that we haven't had a chance to look at yet is what kind of precursor compounds might be out there that are degrading it at the waste disposal sites and producing some of those compounds.
You said something about finding lower levels and assuming that those were atmospheric deposition concentrations. Do you, in Minnesota, do you have like a database or some guidance about what you consider atmospheric deposition concentrations?
So the question was, do we have any guidance about what we consider to be atmospheric? And no, I don't. We don't have any kind of guidance along that line. But just by looking at the concentrations near at and down gradient of the site and comparing them to these tributaries, the only assumption I can make when they're either non-detect or at these very trace levels that are similar to reported levels for atmospheric deposition and runoff is that that's really the source, that we don't have some, other disposal area that's contributing to the concentrations we're seeing in those tributaries.
Thank you. Introduce you? Oh, sure, go ahead.